right, so here is our bell ringer we're going to work through here. We are solving an inequality, and then we are solving an equation for x. Pause the video, have the students work through this if they haven't already, and then I'll go through the answer. All right, for number one, we have an inequality where we want to just solve for x. So let's put the x on the left. It's best to move the x to the left when you're working with these. That way you don't have to worry about making a mistake when you get to your final answer. Okay, so moving the x to the left, subtract 10. We have a negative 3x plus 2 less than or equal to a 5. Let's move the 2 over there. And then we are at a negative 3x is less than or equal to a 3. And then remember, we have to divide this negative 3, and since we're dividing by a negative, we got to flip that sign. So we'll have x is greater than or equal to a negative 1 for the final answer there. Okay? And if you wanted to, you can plug the negative 1 in there and check to see if you get a correct answer when you're done. You shouldn't have to if you follow the steps correctly to get to your actual answer. For the second one, we're solving for x. And this was on the worksheet that you guys had to do the other day. But remember, when you have a variable in both of the terms, those are two different terms because this one has two variables. However, we can take out the x from those two with factoring, okay? So it's kind of like reverse distributive property. We're going to take out these x's. So the x would go in front, and we'd have 2 plus y left in the parentheses. And hopefully you can see that this would get you back to where you started. All right? So then we will solve for x here. Okay, so we have this group here, the 2 plus y, so we can take that and divide it out from both sides. All right, and maybe you want to keep it in parentheses, that way you can tell it's a group, but it's not really necessary. So our final answer is going to be x equals 3 over 2 plus y. Okay, so on the next slide, I'll try to work through a few homework questions that you guys have. Don't worry about this part right here. I've looked up a few of them, and I'll write a few on the board. Okay, a few questions to look at. One class did not go through these. The other class did go through these. So from the worksheet, I have 20, 21, 24, and then from the book is the word problem I have up here. That's number 37, A and B. Those are the ones that we'll go through. Okay, so for number 20, you're looking to solve for x. So there's an x in this one here and an x here. So in order for you to solve for a variable, you got to get that variable on the same side. So we'll have to move this over. All right, so we'll have 2xy minus x equals 7. And then a trick here is we have an x in both of those, so we have to think greatest common factor. So we can take the x out of those, like a factoring problem, and then we'll have 2y minus 1 with the x in front. Okay, so we're just factoring. We're doing like reverse distributive property here. And then to get the x by itself, we're going to divide the 2y minus 1 out, and then we'll be done, because this will cancel here. So we'll have x equals 7 over 2y minus 1. So that's the answer for number 20. Number 21, we need to get rid of the fractions. So there's a trick that we can use to get rid of fractions. You're going to look at the denominators, and you're going to multiply everything by the common denominator between everything. So this is really like 6 over 1. So between a 2, 4, and a 1, the common denominator would end up being 4. So we're going to multiply everything by 4 over 1. And you should see what happens when we do that. Okay? So here on the left, that 4 and that 2 are going to cross cancel. That's the way fractions work when you multiply, right? You cross cancel, and then you go straight across. So the 4 would turn into a 2, 2 turns into a 1, so we'll be left with 2 times d. Here the 4 cancels with both of those. We're left with just a 1, right? So it'd be 1f, or just an f. And then over here, nothing will cancel with this one, so it'll just be 6 times 4, which is 24. So we're looking to solve for f right there, so all we have to do last is move the 2d over. So we'll have f equals 24 minus 2d, or a negative 2d plus 24. Either one will work. Number 24, we want to kind of use a similar approach as both 21 and 20. Okay, we're solving for m. We have an m in this term and an m in this term, so we know that there's going to be factoring somewhere, but we have to get the n out of the denominator. So we want to take everything times n, or n over 1. Okay, because that'll cancel that and get it out of the bottom. And then we'll have m plus 5mn is equal to 20n. So we have the m here and the m here. We got to factor that out, right? Take it out of both of those. So we'll have m1 plus 5n is equal to 20n. And the last thing you want to do, get rid of this group right here. 1 plus 5n is dividing out. Those cancel there. We have m is equal to 20n over 1 plus 5n. And that's our answer for that one. Okay, so I'm not going to read through all of number 37 in the textbook, but it deals with an individual selling advertising space to companies. The individual gets a salary of $250 per week, so that's a constant. We're always going to get $250. And then you get a 3% commission. Okay, that's 3% right there. You get a 3% commission on each billboard that the person sells, and on average, each billboard sells at about $500 a piece. Okay, so that's where those numbers come from. The X represents the number of billboards we're going to sell, and then the 700. I have to figure out how many billboards I need to sell in order to make $700 or more, at least $700. Okay, so we're going to solve A to figure out how many we need to sell. Okay, so we'll have 250 plus, so 0.03 times 500, that is 15x is greater than or equal to 700. All right, so we'll move the 250 over, because we're going to get that variable by itself, and we'll have 15x is greater than or equal to 450 over there. Divide both sides by 15, and we get x is greater than or equal to 30. Okay, so we need to sell at least 30 billboards in order to make the $700. All right, so hopefully that helps you understand the homework questions. If you had other ones and do not want to turn in your homework, please send me an email. Please let me know, and we'll continue with the lesson. All right, so working through a review topic here. Just like the other lessons, we have review topics before we get to the main thing. So we are going to solve absolute value equations and inequalities, okay? Today we're just looking at equations. Tomorrow we'll take care of inequalities. So what do we do when we have something like this, okay? Well, if you remember the idea of absolute value is distance from zero, okay? So we're saying that my x minus 7 here, my absolute value is 7 units away from 0. So it can be over here. And now since we're just saying 7 away from 0, we can also be over here. So I can have a 7 or a negative 7 when I start to solve this, okay? So when I start solving the equations here, I need to set it up where it's equal to 7 and negative 7. So here are some steps that you might want to write down, okay? You don't have to write them down, just make sure we know what we're doing, okay? So we're going to isolate the absolute value signs, okay? That means if there's a number in front like that, or a number being added to the back, we want to get rid of that first, okay? Since there isn't a number here, we're just going to get rolling with it. So make two equations, one positive and one negative. So that's where we're looking at this, okay? So we're going to have the positive equation right there, and then we'll have the negative equation right here. You're not changing the stuff in the absolute value, you're only changing that 7. So we have a positive 7 and a negative 7 when you set that up, okay? So positive equation, negative equation. and then solve both equations, and you'll get two answers, okay? The steps should be the same for both of these. So add 7, and we get x equals 14. And then for this one, we're going to add 7 also. And you see that those will cancel out, and we'll get x equals 0, okay? And then you want to check for your final answer. If I put a 14 in there, 14 minus 7 gets me a 7. Absolute value of that's still a 7. All right, then let's check it with the 0. So if I put a 0 in there, 0 minus 7 is negative 7. Absolute value of that gets me back to a 7. Okay, so that's how we solve absolute value equations. Okay, so I would like you guys to try this one next. So go ahead and pause the video and see if you can get an answer for this one. All right, so we need to make two equations. So we need to make a positive equation and a negative equation. So 5x minus 10 is equal to 45. 5x minus 10 is equal to negative 45. Okay, so there, to go from there, we can just keep going with it. So add 10 to both sides. We have 5x equals 55, so x equals 11 when we divide both sides by 5. Add 10 here, add 10 here. We have 5x equal to negative 35. Divide both sides by 5, just like in the last one, we get x equal to negative 7. Okay? And I'm going to save some time. I won't check this one because I know that it's going to work out. Okay? So now occasionally you could run into some questions like this where we have maybe like 2x minus 5, the absolute value of that is equal to a negative 3. When we do run into something like this, you should ask yourself right away, does that make sense? Can I have an absolute value equal to a negative number? The answer is no. So when you run into something like that, the automatic answer is no solution. Okay? So those are the absolute value concepts that we were looking at before we get to here. All right, so today we're covering rate of change and writing linear equations. That's your heading. And then the next lesson will be the second part of 1.4 and going into 1.5. Okay, so rate of change. We got a definition for rate of change. It's a ratio that compares the average change in one quantity, okay, change in one quantity versus change in another quantity. Okay, this is a fancy way to say slope. A lot of us should know what slope is. It's just rise over run, so you're comparing the rise over the run. The first part, working with rate of change, will have some scenarios where you have to kind of figure out the change in the specific scenario. Okay, so looking at the first one, we have a college admissions at UCLA. We have from 2004 to 2006. So we're going from 56,878 in 2004 up to 60,291 in 2006. We want to find the rate of change in the number of students applying for admission from 2004 to 2006. Okay? So we want students per year. Maybe you want to think about how it should be arranged. So it's students per year for my rate of change. Okay? Let's find the change in students first. So that's going to be 60,291 minus 56,878. Okay? Which if you just throw it in a calculator quick, you get 3,420. All right, that takes care of the change in the students. Now at the bottom, we want to find the change in years. That one's a little more obvious. We're going from 2004 to 2006. Okay, so let's do, so we keep everything positive, 2006 minus 2004. All right, so when we're working with people, you don't want to have a negative, or people or time, you don't want to have a negative, so we'll try to keep everything positive, and that's just 2 years. Okay? So when you actually put that fraction in your calculator, you get 1,710, and that's students per year. So we can use this information to kind of predict or extrapolate. We'll say maybe in 2007, we'll be at about 61,000, 63,000 maybe, because we have another 1,710 students. Okay? So that's how you would use rate of change in a scenario such as this. We have a couple of different options that we can calculate rate of change. So the last one was just using information that we're given. The next one here, we're given a table. So we want to use this table to figure out the rate of change. Okay? So we have a distance that something is moving over a time. Okay? So we have 2 minutes, 4 minutes, 8 minutes, 12 minutes, 14 minutes. And then we're going from 8 to 56 feet. So in order for you to find the rate of change, you have to be comparing two quantities. So I would look at the first data point and the second data point. It doesn't really matter which one we choose as long as we're choosing two. So this one's a little bit simpler than the last one. The numbers are a little bit smaller. So the distance that we're going across, all right, so we want to figure out the difference in the distance. So 16 minus 8, that would give me 8 feet, right? So it's distance, and then we're comparing it with that time quantity, 4 minus 2, and that is 2 minutes. Okay, so you see what we did here? We found the difference in this quantity and the difference in that quantity, and we made a ratio with that to find the rate of change. So it's how many feet are we going per minute is what we're looking for. So if we do 8 feet in 2 minutes, that means we're just going 4 feet per minute. Okay, we would actually divide the 8 in 2 and you get 4 feet per minute. Okay. Another one down below, we could be looking at a graph. Okay, so the graph here is showing data on the fastest growing restaurants chain in the US during a specific time of growth. So we want to find the rate of change from 2001 to 2006. So from 2001, that's here, to 2006, that's here. Go ahead and see if you can figure out the rate of change of these restaurants. So go ahead, pause the video for about a minute or two, see if students have an idea for how to find the rate of change in this graph. Okay, so you could have looked at just maybe up and over for those and see what happens, but you'll see that they don't have a consistent rate of change from one to the next, right? It's not the same. So what you want to do, since we're going from 2001 to 2006, you're going to use those endpoints of the graph just to kind of get an average rate of change. So right here, that kind of lines up over here. So we could say that that might be about 33. So it's in thousands of stores. So let's just say 33 and then give our answer in thousands in the end. And then down here, we want to figure out stores per year also, if you didn't figure that out. So this is what we're going to have. We'll have stores per year when we're done. So we have 33 in the end. We've started with 6. All right, so kind of eyeball that where it lines up. It's not at 5, so we'll say it's about 6. And then the bottom is going to be the time. So we're going from 01 to 06, so that's 5 years. All right, so a little bit of simple math here. 33 minus 6, that's going to be 27. The 5 stays the same. Okay, so when you put 27 over 5 in your calculator, you get 5.4, and this is stores per year. All right, but remember we started with, it was in thousands, so we could say 1,000 stores per year. So about 5.4, maybe close to 5,500 stores per year would be the rate of change for the restaurant chain here. Okay, so we covered finding the rate of change from words, and then a table, and now a graph. Okay, so I'm not going to have you guys work through this, but similarly to the last one, we would take the end point and the starting point, and you'd find like an average rate of change to get from one to the next. Okay, that's the rate of change that we're looking for, just an average rate of change. All right, so let's take a break here quick. So please stand up. We'll stay in the room for the brain break. You can stand up, stretch out a little bit, and then this is your brain break that you want to do for today. So you're going to attempt to rotate your right foot clockwise and draw a 6 with your left hand. Okay? Once you have that, you can switch hands to see if it is a little bit better, and switch feet. So you would take your left foot and go clockwise and then try to draw a 6 with your right hand. Okay? So give about 3-4 minutes maybe for the brain break, and then get rolling again. All right, so find slope and rate of change. How do we do that when we're actually looking at a linear equation, a line? How do we find slope of a line? Okay, we got slope formula. So we have learned slope formula before. I will give you kind of a symbol here. We have change in y over change in x. That's how we're going to get slope formula. And if you remember, slope is written as m when we put it in our equation. So this is what we're going to do. y2 minus y1 over x2 minus x1. And that's how we calculate the slope when we are given coordinates. So you might want to write that down somewhere. It's not on the wall in the classroom, and you'll need to use it for your homework if you don't remember the slope formula. Okay? Another way, maybe if you're looking at a graph, you're going to do rise over run. So you're going to count how far up or down, and then how far left and right. I always go up and right. Okay, I always go up and right. That's the best way to do it. That's the best way to calculate slope. Okay, up is going to tell, I guess you might go up and right or down and right, but regardless, I always go to the right. That's the best way to do it. Okay, so slope formula down here, I gave that to you. Make sure you have it somewhere. On to the next slide here. So we're going to calculate the slope of these two. So I'll help you with the first one. You do the second one, and we'll give you the answer in a second. Okay. So my slope formula, y2 minus y1 over x2 minus x1. If you need to, you can write x1, y1, x2, y2 by your coordinates here. It might help you organize things. Okay, so we're going to subtract the y's. So -1 minus 3 over, subtract the x's, 2 minus a -1. Okay, so right here is where you got to be kind of careful. You're subtracting a negative. Those turn positive, and we get -4 over 3. And this is what you want to leave it as. Do not change it to 1 1/3. Don't change it to 1.3. Leave it as -4/3. Okay. Go ahead and try the second one here. So pause the video and have the students work through that, and then start it back up, and you'll get the solution. Okay, so we're going to subtract the y's, -5 minus a -3, over subtract the x's, 1 minus 4. Double negative becomes a positive there, so on the top we have a -2, on the bottom we have a -3. Again, we have a double negative, which turns back to positive, and we have a slope of 2/3. Okay, so let's double check this. The y minus the y, yep, and then the x minus the x, and we got it. Okay, looking at a graph is actually pretty easy. Okay, I told you a little bit ago, you do rise over run, and we just count. Okay, so when you're looking at the graph over here and you're trying to calculate the slope, you find nice points where the graph will go through. So when I say nice points, it's right through the corner of the boxes. Okay, so if I'm looking here and I'm counting, I do rise over run. So I went down 1 unit, and then I went right 3 units. So down is a -1, right is a +3, so it's -1 over 3, which is a -1/3 slope. Okay, that negative should be out in front of the fraction like that to signify a -1/3. Okay, so for the next one here, do the same thing. So look at that quick. Find a couple nice points that are actually given to you. Share what you think the slope is going to be with your table partner. And then see the answer is 1/2. Okay, so I went up 1 unit over 2 units. So rise over run is 1/2. So the next thing, since we have an idea how to calculate slope, we're going to start writing linear equations. So this is the linear equation, or the form of a linear equation that you all have learned before, y equals mx plus b. That is called slope-intercept form. Today we're going to take care of slope-intercept form, and then the next class we'll be taking care of standard form. Okay? So we want to write an equation of this line in slope-intercept form. Sometimes it's nice. So I'll write the equation here. Sometimes it's nice and we have a nice intercept. Okay, this is my slope, and this is my y-intercept. And the y-intercept is just where it crosses the axis. So we can see right here, that's not a really good number. I don't know exactly what that is without estimating that. So I'm going to have to calculate the slope, and then I'm going to have to calculate the y-intercept. So slope is pretty easy here. I got rise over run. I went down 1, right 3. So I know my slope is a -1/3. Now I don't know my y-intercept. There's a couple ways to calculate that. The best way with slope-intercept form is to take one of your points. Okay, so that would be a -1, 1, 2, 3, 4. We're going to take one of the points and my slope, so these two things, and we're going to plug them into my slope-intercept form. Because remember, this really is an x and a y. So that's how we can plug it into our slope-intercept form. So we plug that in. So 4 goes for the y. M is a -1/3. And then my x is a -1. Okay, hopefully you see what we're plugging in there. And then my b I don't know, which we're going to calculate. All right, so then we do a little bit of math. So this gets me to a +1/3. So 4 equals +1/3 plus b. And then I'm going to have to put the 1/3 on the other side. So we're doing inverse operations here. So we're going to move the 1/3 over. So 4 minus 1/3. The calculator will do it for you, but you want to make sure it's in fractions, okay? I'll do it over here, remind you how to subtract fractions. So this is like a 4 over 1, okay? And then we got to get a common denominator, so that means we'll have to take this one times 3 and subtract. So it'll be like 12 minus 1, which is 11/3. So we get b equals 11/3. Now, I don't technically have my equation yet, but I have everything I need. I have my slope, I have my y-intercept. We just write it out with those two things in there now. So y equals -1/3 x plus 11/3. That's the equation of this line. Okay, so 11/3 is about, what is it, 3 2/3. So 1, 2, 3, and that must be 2/3 right there. Okay. Let's try this one. Okay, so we'll try this one together. We'll do the same thing. So my slope, down 2, so that's -2, and then over 6. Okay, just by the points that we're given there. We could have done it a better way. So -2 over 6, we want to reduce that. That's -1/3. So my slope will say m equals -1/3 again. We're going to use that. And then a point here. This is the one that I would use, 0, 3. And guess what the nice thing is with this equation? Our b is a y-intercept, right? This is a y-intercept. So it's b equals 3. So then we can just put those right in our equation right away. Okay, so sometimes you have those nice y-intercepts that you can use to get the equation of the line. So my line is y equals negative 1/3 x plus 3. Okay, it has a slope of negative 1/3 and a y-intercept of 3. Point slope form is the last thing we're going to talk about. Okay, and point slope form can be easily changed into slope intercept, but if you don't remember, this is point slope form right here. I'll write it a little bit bigger. Right there. So this is my slope, and the x and y come from a point that I'm given, or a point that's on the line. And I'll show you guys how to calculate that here. Okay, first one's fairly simple. Write an equation in slope-intercept form for the line that has a slope of negative 3/5 and passes through 5, negative 2. So we could just do like we did in the last slides and find b by using the slope and the point. I'm going to show you guys how to do it, or how to find the equation by using a point slope form. Okay, so point slope form again is y minus y1 equals m x minus x1, where the x1 and y1 are a point that I'm given, okay, and the m is a slope. So again, if you need to, x1 comma y1, if you need to write that there, so you can kind of figure out where to put what. So y minus the y coordinate, negative 2, equals my slope, negative 3/5, times x minus the x coordinate, which is 5. Okay, so before you want to call this slope intercept, or excuse me, point slope form, we got to take care of any negatives floating around and then write it a little bit nicer. Okay, this right here is my point slope form. If I was asked to put this in point slope form, I'd be done. But we're going to slope intercept form. Okay, so in order for us to get them to slope intercept form, we got to move this over, but we have to distribute this stuff first. Okay, so those are the two things that need to be done in order for this to be slope intercept form. Okay, so let's do the distributive stuff here first. So we got y plus 2 equals negative 3/5 x, and then we got a 3/5 times a 5. What happens when I take 3/5 times 5? That's like 5 over 1. We multiply fractions, those will cross cancel, so that's just a 3. Okay, 3/5 times 5 is a 3. And then our last step, move the 2 over, make sure we subtract it from the correct term. That doesn't go with the x. And we have negative 3/5 x plus 1. That is your slope-intercept form. Okay? So if I took this equation and graphed it, it would look exactly the same as that equation. Okay? So I'll have you guys try one more of these. Okay, so do the same thing as what we just did. So take this, write it in point slope form, and then change it to slope intercept form. So pause the video for a couple minutes, and then resume the video for the solution. Okay, so plugging it in, y minus y1. So y1 is a negative 1, so that'll turn this to a positive, right? We'll have a double negative there. Slope, 2/3. X minus x1. x1 is the negative 3, so again, that'll switch. Okay? This is my point slope form right here. Now I want to change that to slope intercept. So distribute of y plus 1 equals 2/3 x. 2/3 times 3 is a 2. Move the 1 over. And then we have y equals 2/3 x plus 1. That is the equation in slope-intercept form. Okay, so we used our point slope form and got it to slope-intercept form down there. Okay, so that concludes everything. So hopefully Everything makes sense. I'll have the video in Google Classroom for you guys to look at, or I'll have it on my YouTube channel as well. This is your assignment. Try to work through that for the next class day. Thank you for watching.